Alright, what's up, Super Team, and anyone else that is tuning in to learn how to implement full text search with a PostgreSQL database. Shout out to Ben Awad, who I was able to watch his YouTube tutorial, and everything was so clear and so nice in terms of his explanation of how to implement full text search on a PostgreSQL database. So basically, I wanted to create this video to one, explain what full text search is, and then also how it's working in our database for the Labs15 endorsed career tracker application for our project. Ryan Holdaway grilled me on my first Labs 12 project, and I did not know the answer to his question when he asked, what are the implications of using fuzzy search versus full text search? Why would you, if you're going to scale, what kind of search would you use? I froze. I didn't know the answer. The real gist of it all is that I should have been more prepared, and I should have had a very good understanding of each portion of the tech stack. So this second go around as a TL, I wanted to make sure that my understanding of the back end was as good as the front end, was as good as the README, right? So, all right, so check this out. So this first query we have, so basically we have a database that stores tables of users for our application. So that we're just going to focus on the users table. And so that's the public.users that you see right here. And then this first query that I'm going to run is going to return every single user, right? From the first name, last name, and email columns. So I'm just going to highlight this, click that, and boom. We have 1,003 rows that are returned when we run that query. Okay, so that's just a regular query right there. Regular SQL query. Okay, so this query here uses something called to_ts vector and to_ts query to match all records from these columns, from the first name column, actually just from the first name column, yeah. Any records that have the string Tico in there, just like it is here, will be returned. So let's highlight this query, run it. Okay, so we get 2 Tico records, because I signed up for it twice. 2 separate emails, as you can see here. Okay, so not bad. And then we're going to look at something called, actually, yes, so, sorry. So using the same syntax here, where you use the to_ts vector, and we're searching the first name column for any records that have the Tico string in there. In this next query, what we're doing is we're searching for this string Tico inside of the first name column and the last name columns. And in SQL, these double pipes, these are the concatenator operator in SQL, just like a plus sign in JavaScript, and then we're just adding in a space in between those columns in the query. Okay, so let's run this one. There we go. And we return the same because there's no last name records that have Tico string in them. Okay, and then this one here, we're doing the same thing. We're just adding another column. We're adding the email column to demonstrate that we can search all 3 columns using TS vector and TS query for this string Tico here. So let's run that. And just to show you it does change, I'm going to change this to Bob for you, because we do have a Bob in our database. And let's highlight this, click that, and we do return Bob Ross. With the email bobross@happylittlemistakes.com. There we go. Okay, change this back to Tico. Okay, scrolling down, so that is what's considered just I believe that's like a, yeah, full text search using TS vector and TS query. So we want to make it a little bit faster, right? So what we're going to do in this next query is we're going to create a new column. It's going to be called document, and we're altering the table to add a new document column, and then we're going to set document equal to the pre-computed vector value. So in all of these 2_TS vector, yada yada yada, all of these queries, what's happening is it's calculating a vector value on the fly, according to Mr. Ben Awad in his YouTube video tutorial. And then what we're doing here in this latest query is we're creating a document column and adding it to our existing table, public users, and then we're pre-calculating that vector value and just plugging it in there into that record as a value for that column. So then what we would do is we would just query the document column for that value instead of having to calculate it on the fly. It's pre-calculated and it's just stored, right? So let's run this here. It's not going to work because I already ran it. Yep, so I already did alter the table. So let's go down here and let's just go straight to a query. Okay, so this first query, so we're selecting all the records from the document column that match this TS query string here, Tico. So let's try that. Boom, we get both right there. Pretty nice, pretty nice. Okay, so now we're going to run a speed test to see what the difference was between the full text search query with the dynamically calculated vector values and the full text search query with the pre-calculated vector values that were stored in a new document column. Delete that on there we go. Okay, so let's do this one again for Tico. Okay, so query number 1. Let's see how fast it goes. Okay, so we'll expand this view for you here. Boom. So you can see that it took 11.99 milliseconds to execute that query number 1. So let's scroll down here and put 11.999 milliseconds for query number 1. All right. So still in speed test number 1, let's check out query number 2 and see how fast that is compared to the first test, which was like we're calculating those vector values on the fly, versus here we are creating a new document column and storing pre-calculated vector values in that column, and then we're just querying the table for that. Okay, so this here. All right, so you can see right there that it pretty much like decreased the time by half, right? 5.977 milliseconds. Compared to the first one, which is 11.999 milliseconds. Okay, so now we're going to try to make it even faster. I know you're thinking like, how, Tico? Well, Ben Awad will show you how in this tutorial. I'll just demonstrate it for you as well here, though. Okay, so in this this third way we're going to make it faster. We're going to create a new document with index column that adds a GIN-based index. So GIN meaning generalized inverted index. Not really sure 100% what that means. I just know that it works really, really well. Okay, so yep, so we're altering the table. We're adding a column called document with index, and it's with the type TS vector. It has to be type TS vector. And then here we update the table, and then here we're setting this variable here, document with index, to equal that TS vector query from earlier, the TS vector statement from earlier. And all of this coalesce keyword right here means is it's basically used for any values that might be empty or I believe have null as a value. So we technically don't need that because in our database, first name, last name, and email are all required. But basically it would just push this empty string in so that you wouldn't have a null value there, which would mess up like whatever data is returned. Like you won't have anything returned. So that was just from the tutorial. I can just get rid of that there though, so we don't need it. So we just say email like that, and in here create index. So we are creating an actual index called document index, and then we're going to update it. Sorry, on the public.users table, and then we're going to be using something called GIN, which we saw up here, is generalized inverted index, and basically we're setting that document index on the document with index column, inside that column. Okay, so if I run this query here, it's not going to work because I've already done that. So now we're going to go to the speed test number 2. And for speed test number 2, we're going to compare speed test number 2 to the new query, speed test number 3. Speed test number 2, remember, took 5.977 seconds from earlier, but we'll still run it anyways to see how fast it goes. Okay, so it took 2.251 seconds. And what we were querying was the document column for this Tico string here. Right? Okay. So we're going to put that right here. It's the second time to do that. So that, remember, that query is the same exact query from up top here, from speed test number 1 that we did. So right here, here's speed test number, or sorry, query number 2 from speed test number 1. It's the same exact query as what's in speed test number 2. Same exact query, no different. And you can see though there was a variation in the time there that it took. All right, and then the last query we're going to check the speed for was the full text query with the GIN index that was stored inside of the document with index column that we added to the table. So that's different from this one because this one does not have the GIN index, it just has the new document column. This one we added the new document with index column, and then we put that index in there, the GIN index, which speeds things up even more, as you'll see here. So this. So that took 0.043 milliseconds. You can see that's pretty fast. So let's put that down there. So query number 1, remember that was just using, we're just basically dynamically calculating those vector values on the fly, and then returning those records, and that took about almost 12 milliseconds. And then in the second query, we are pre-calculating those vector values and storing them in a new document column, and then querying that document column. And that took, I guess, on average, like 3 or 4 seconds, right? 3 or 4 milliseconds, sorry. And then when you add a GIN index to that new document column or document with index column that we've created, it has significantly decreased the time it takes for that query. So performance is amazing if you have a GIN index in there. So that's how we're going to be implementing full text search into our backend, our Postgres database on our backend for the Endorsement Tracker Project. Thanks for watching.